Hey guys, so here's part 2 of the 10.4 notes. We're going to continue with our compound events. Now make sure that you have your the card handy and then maybe the dice. Remember, you can find all that on Schoology in our 10.4 folder. Okay, so let me go ahead, or actually in our this will be our Tuesday folder. So let me go ahead and show you where you can find it. So if you go into Schoology, it's going to be our week 17. It's going to be our Tuesday folder. And here you'll see the cards handout and the sum of the dice. So this is really going to help you during these notes, but also during the homework assignment. So make sure you're using this. Okay, let's go ahead and get to the notes again. And I'm going to have my cards ready so we can use those if we need to, okay? Okay, so it says a card is randomly selected from a standard deck of 52 cards. Find the probability of drawing the given card. So we're only drawing one card. So the probability that it's a 4 and a jack, okay? Now notice here, right, if we look at all of our cards, and I'm going to go to that, okay, is there a possibility that we can have, if it's just one card, that it's both a 4 and a jack? Well, we have 4s and we also have jacks. But we can't have where one card is both a 4 and a jack. So this is actually our disjoint event. So remember we talked about that? Basically a 4 and a jack don't have anything in common. And because it said it is an and, so probability of a 4 and a jack, that means since they don't have anything in common, our probability here is going to be 0. Okay, so now let's figure out the probability that it's not a red. So we just need to make sure we have everything else. So remember when we talked about our complementary, something that we don't want in that event. So think about not red as our event A. We don't want it. So this would be our complementary event. And remember, to do this, we basically are doing our prime. We're going to do 1 minus the probability that it is a red, okay? Now, do you need to memorize, like, oh, this is a disjoint complementary? Not really. There are easier ways to do this, or a different way. I shouldn't say easier, but different ways of doing this. So I'm going to kind of show you both. So we can do 1 minus the probability of red. So if you need to go to your cards and count how many red, you can do that. Remember, we have 52 cards total, and half of them are black, half of them are red. So that means we really have 26 that are red. So I'm going to do 1 minus, and I'm going to do this as a fraction. So we have 26 out of 52 of them as reds. So that means, and you can plug this into your calculator, we will get 26 out of 52, okay? Another way of doing this is if we don't want red, well, the opposite has to be the probability of figuring out it's black, correct? So then another way of doing this is just finding the probability of a black card. So that's going to be, once again, 26, because there's half red, half black. So there are multiple ways of how you can find the answer. Okay, so once we've gotten that, then we're going to go ahead, we need to make sure we simplify. Now notice it doesn't tell us if we need to write this as a fraction or decimal, so remember that means it is up to you of what you would like to do. So we need to simplify this, and we can do that using our calculator if we need to. So if we want to do our 1 minus, we can do that. So we have 1 minus, and you can do 26 divided by 52, okay? So you can write your final answer as a decimal, which is 0.5, or if you rather write it as a simplified fraction, remember you can go back to math and then press enter to get your fraction, and that's going to be, of course, 1/2, okay? And as I said, another way of doing this is figuring out the probability of black, which of course is going to be that 26 over 52. Okay, so just another way of doing it. Okay, now let's look at C. We have the probability that it's A or an ace. Okay, well, let's think about this. Does a 10 or an ace have anything in common? Well, let's kind of look here. No, not really. So we just have tens and we just have aces, which are on this side. So that means these are still our independent events. Really, this is a disjoint event. But since it's an or, what we're going to do is we're going to add the probabilities here. So if it's a 10, let's count how many tens we have. 1, 2, 3, 4. So that means out of all 52 cards, we have 4 of them. Then how many aces? 1, 2, 3, 4. Same thing. Okay, so since it's an or and it's disjoint, we're going to add the probabilities. So we're going to have the probability that it's a 10 plus the probability that's an ace. So the probability of 10, we had a 4 out of 52 because there's 4 tens. And then for ace, same thing, there was 4 total aces. Now, remember, when we were doing fractions and they have the same denominator, so common denominator, we add the numerators. So we have 8 over 52, okay? So either we can simplify this, and really 4 is going to go into both of these. So that's going to be 2 out of 13. Or you can write your final answer as a fraction. Let's go ahead and plug that into our calculator. And I'm going to go ahead and round to 4 decimal places. So we have 0.1538. And that'll be our final answer there. Okay, let's do our last card problem here. Probability that it is a face card or a spade. Okay, so once again we have ors here. So we have different things. So let's look. Okay, so if you don't know what a face card is, that is going to be basically your, king, queens, and jacks. Okay, so that's what a face card is. And then the spade, that's going to be one of our black cards. So we're going to look there. Okay, so here, these are our face cards. And then wondering if it's a spade. Now, notice here that our face cards can also be spades. So actually, our face cards and spades have something in common. So this, if we go back to our notes, is going to be an overlapping event. So to do this, we're going to have the probability that it is a face card. And then plus the probability that it is a spade minus, now since this is an or, we're going to have the probability that it can be a face card and a spade. Okay, so that was one of our formulas we did with overlapping events. Okay, so now let's kind of count. So let's go back to our cards and figure out the face cards. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 out of 52. And then probability of spades. So if you don't know this, because there's 4 suits, that means there's 13 cards in each suit. So that's going to be 13 over 52. Now we need to count where they are face cards and spades. So that's going to be 3 of those. So face cards, we have 12 total out of the whole stack. With the spades, there are 13 total of those. And being face cards and spades, there's only 3 of those. So remember, when you're doing these calculations, because they all have the same denominator, all we have to do is either add or subtract our numerator. So we have 12 plus 13 minus 3, and that gives us 22 over 52. And don't forget, we do need to make sure we simplify our fraction, or you could do it as a decimal around 4 places. So our final answer could be 11 over 26. another way of saying this, if we do 11 divided by 26 in our calculators, can be 0.4231. And that would be our final answer. So you can see definitely using the card handle is going to help a lot. Okay, let's go do our next problem. Okay, now we're going to deal with dice. Now I do also have a handout for that, so if you need to, as I said, there's the sum of two dice handout that might help. Okay, so it says when two six-sided dice are rolled, there are 36 possible outcomes. So that's what's going to be the number that goes in our denominator when we write this as a fraction. Find the probability of the given event. Okay, the sum is not a 6. So this is kind of like our complementary event. So anytime it's complementary, that means what you're going to see is not or no or something like that. So to do that, we're going to do 1 minus that the probability. The sum is a 6. Okay. Now, what I'm going to do here is actually use my cards because I think they're a little bit easier to read than these dice. Here we go. So notice, once again, six-sided dice. So we have this here. All these numbers are the sums. So we need to make sure we add up all these sums of 6. So anywhere you see the number 6, add them up. So we have 1, 2, 3, 4, 5, and that looks like that's it. Okay, so we have 1 minus. Now remember, there are 36 possible outcomes. So that number is going to go in the denominator. So we go ahead and plug this into our calculator. We can either write this as a fraction or as a decimal. It's kind of up to you because they don't show or tell you what you need to do exactly. So as a decimal, we get this. And then if you rather write it as a simplified fraction, remember we can go back to math and change it. So we have either 31 over 36, or, how to choose 4 decimal places, 0.8611. Okay, let's go and do part B here. So the sum is less than or equal to 9. Okay, so what we're going to do here, okay, is actually just add up all the sums that are 9 or less, because it says sum is less than or equal to 9. So going back to my sum of the two dice, I'm going to start with 9 and count. So I have 1, 2, 3, 4. Now it does say less than, so that means we want sums of 8, 7, 6, 5, 4, 3, and 2. So as I said, there was how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So there's 30 possibilities here. So basically, this is just going to be 30 over 36. That's all you got to do, okay? So there's really no, because we don't have multiple things, you're just adding up. Now, we do need to make sure we simplify this fraction. And so we know that 6 can go both into these values. So we have 5 over 6. Or what we can also do is write it as a decimal, which is going to be 0.8333. And that'll be our final answer. Okay, make sure you watch part 3 of the 10.4 next.